Will Polkadot have a hard time after Ethereum 2.0 goes live? Hi, it's Trace from Polkadot. The upgrade of Ethereum 2.0 has been in the spotlight. Ethereum plans to switch from proof of work to proof of stake in the second quarter of 2022, and the upgrade road has also been adjusted recently. Some remarks believe that after the successful upgrade of Ethereum to 2.0, the existing problems of Ethereum will be completely solved, and Polkadot will have no chance to surpass. So, is this the case? Ethereum 2.0 and Polkadot do have some similarities, such as adopting sharding technology, POS consensus, randomly assigning validators, and so on. This video will compare the similarities and differences between Ethereum 2.0 and Polkadot, combining the latest upgrade, roadmap, and their respective development progress. So first, design goals. Before we start the specific comparison, let's understand the design goals of Ethereum and Polkadot, which is probably the biggest difference between them. Ethereum aims to be a platform for smart contract execution. There's no doubt that Ether is innovative and it has created a new track of application-based blockchains. However, the limitations of Ethereum were also quickly highlighted: network congestion, expensive node operations, proof of work, consuming a lot of energy, etc. Since 2014, the Ethereum community has been seeking solutions to these problems and has embarked on a protracted upgrade path. As a result, it is still a smart contract platform. It's just going to become more scalable, secure, and sustainable. And Polkadot aims to be a layer 0 blockchain, helping everyone create blockchains, providing shared security for those blockchains and allowing them to easily interact with each other across chains. Second, the principle of sharding. Both Ethereum 2.0 and Polkadot have chosen to shard to improve scalability. The difference lies in the state transition function, which is the rule governing how the blockchain changes the state of each block. The main chain of Ethereum 2.0 is called a beacon chain, and each sharding is a chain with an ETH2 interface, with 64 sharding in total. Each one has the same state transition function that provides the interface for smart contract execution. Contracts exist on individual sharding, so they can be scaled by executing them in parallel. However, the sharding in Ethereum is still in the conceptual stage, and the community is still discussing future options. In the latest version of Ethereum website, it is mentioned that perhaps the sharding chain will be considered as a data layer only, providing additional data to the network only, without processing transactions or smart contracts, or only a part of the sharding will process contracts. In the Polkadot network, the master chain is called a relay chain, and the splits are called parachains. And each relay chain is expected to support 100 parallel chains. The most important difference is that Polkadot uses WASM as a meta protocol. The parachains are not limited to a single interface like ETH2, but can define their own logic and interfaces and simply provide their own state transaction functions to relay chain verifiers to execution. In other words, parachain developers have the freedom to define their own rules for how their chains change state, and you can write any computer program in any language you like, as long as it compiles into WebAssembly. Applications can exist within a parachain or can be deployed across parachains. Ethereum 2.0's sharding is what makes the original Ethereum model more scalable and can handle more smart contract transactions. Polkadot's sharding is not limited to smart contracts. Each parachain can be made into a completely different chain. For example, one parachain can be a smart contract chain similar to Ethereum, and another parachain can be a chain built for DeFi applications, and another parachain can focus on NFT. For example, in the case of Ethereum 2.0, there are too many work tasks for one employee to do, so they are divided into n interns. But the work they can do is still the same. In the case of Polkadot, there are different business departments such as sales, marketing, and technology, each responsible for their own business. Third, consensus mechanism. Both Ethereum 2.0 and Polkadot use the hybrid consensus model, which means that different protocols are used to manage block generation and block termination. Both of them use different protocols for block generation and block termination, assign verifiers randomly, and can terminate a bunch of blocks in one round. The difference between the two is mainly in the block termination time and the number of validators required for each sharding. Ethereum 2.0's termination protocol, Casper FFG, terminates blocks based on epochs, with block terminated every 6 minutes, up to 12 minutes. In contrast, Polkadot's termination protocol, Grandpa, terminates blocks based on availability, with an expected termination time of 12 to 60 seconds for a block bench. Ethereum 2.0 requires a large number of verifiers per sharding to provide validity guarantees. Polkadot overcomes this problem by assigning corrective codes to all verifiers in the system, which allows anyone to reconstruct a parachain block and verify its validity, allowing Polkadot to provide strong validity guarantees with fewer verifiers per sharding. And next, staking mechanism. Ethereum 2.0 adopts the proof-of-stake mechanism, which packs 32 blocks per verification circle. Verifiers are rewarded once per poach. The beacon chain randomly divides the verifiers into multiple committees and assigns them to specific chunked blocks during the verification process to provide validity guarantees. Ethereum 2.0 requires a large number of verifiers in order to run the network properly. Each sharding needs at least 256 committees to finalize all in one epoch. So 64 shardings would require 26,384 verifiers. Polkadot, on the other hand, uses the nominated proof-of-stake mechanism, which allows some holders to nominate validators through pledges, so that they can share the block rewards without running validators themselves. Using the NPOS mechanism allows Polkadot to have fewer verifiers, with each parachain requiring only about 10 verifiers. So 100 parachains would require only 1,000 verifiers. Although there are not yet 100 parachains, Polkadot has already launched an early 1,000 validators program to help increase the decentralization of nodes. The next, governance. Ethereum 2.0 still does not address the governance issue. Currently, Ethernet mainly relies on off-chain governance, such as GitHub discussions, developer meetings, Ethereum Magicians Forum discussions, etc. Polkadot uses an on-chain governance mechanism. There are various channels for proposing motions, such as on-chain concourse, technical committees. All motions are subject to a public vote, which is in the hand of the token holders. After the vote is passed, the motion will be executed on the chain itself. From how funds are allocated from the on-chain treasure to modifying the underlying code of the chain, all are decided and executed through the on-chain governance process. Next, upgrade method. The upgrade method of Ethereum 2.0 still relies on the conventional hard fork, which requires verifiers to upgrade their nodes to achieve protocol changes. Polkadot uses WASM meta protocol to upgrade the chain without a hard fork. The last one, progress. The Ethereum 2.0 upgrade is an ambitious project carried out in phases and was originally planned to be completed in 2022. Ether has recently updated its upgrade road, taking into account that Layer 2 network solutions, such as rollups, have somewhat mitigated scalability issues, and Ethereum has done prioritized sharding to focus on the transaction from proof of work to proof of stake first. The latest Ethereum upgrade path consists of 3 phases: beacon chain, merger, sharding chain. Polkadot went live with a relay chain in May 2020 and a parachain in December 2022. Polkadot has completed the core functionality, and the next focuses will be on the continued launch of the parachain, as well as the upgrade of the interchain messaging protocol and the addition of features such as paraswap. As we can see, although Ethereum 2.0 and Polkadot have some similarities, and the two projects started at similar times, Polkadot's progress is undoubtedly ahead of schedule. As to how far ahead of it, depending on when Ethereum 2.0 will go live. So that's it for today's video. If this video is helpful to you, just like it and subscribe to us. And here are some media channels about Polka World. Some more information about the Polkadot ecosystem can be learned by following Polka World. So welcome to follow us and see you next time.